We started?
Yes.
You are welcome to Multi-User Science Research Laboratory, Ahmadu Bello University. The lab is the central lab of this university. In this lab, it is a central lab and there are different units of the lab. But right now, we are in the NMR laboratory. We will take some time to show you how this equipment works. My name is Silas Ekulibe, and I am the laboratory manager of this Multi-User Science Research Laboratory. So I will take some time to discuss with us how this equipment works. First and foremost, I would like to say that it is quite safe to use the NMR. But when we are working with the NMR, as much as possible, you try not to go too close to the machine with anything that is metallic or with any electronic. First of all, make sure that I remove my watch. I've done that already. I kept my watch outside the magnetic field. You can see a red line here. So whenever you want to operate the equipment, you make sure that you don't go in here with any metal, either your phone or your credit card. I think we can see this. Please focus this. It says magnetic media and ATM credit cards. Strong magnetic fields are present that could erase magnetic media such as floppies and tapes, disable ATM and credit cards, and damage some watches. Say do not take such objects closer to the magnets than the 5 gauge warning. So what we're trying to say is that there is a magnetic field around here. So you don't go near the equipment with anything metallic, anything electronic. There are 3 basic units of this equipment. Number 1 here is the console. The console is more or less a processing unit. So whatever happens in the NMR is monitored, regulated. The signals are modulated in the console and is sent to the workbench over there. This is the workbench. You know, it's a modern equipment that is interfaced with a system, with a computer. So we manipulate and control this equipment from the workbench. This is the NMR 400 megahertz. This is 400, that's what we have here in A.B.U. There is higher models like 600, 900. Basically, the NMR is used for elucidation of structures. Maybe you did a work on natural products or synthetic products, and you want to know the structure of what you have done. You bring your sample to this equipment. We run for the proton and for the carbon 13. And from the signals you obtain from the equipment, you can interpret your signals and be able to come up with the structure of whatever you are elucidating. I think that's the main purpose of this workshop. So that when we get signals or obtain signals from this equipment, we should be able to handle it. We should be able to treat it and come up with the structure of that equipment. Right away, we are going to show us practically how we analyze samples when sample come to the lab. We first of all register the sample, and when the sample comes, we prepare the sample. This is my preparation table. For today, for this exhibition, I would like to take a sample that is very, very common with a lower molecular weight, sucrose. Sucrose, this is sucrose, this is a piece of sugar, it's majorly sucrose. So we are going to run it. I've already got a little quantity of the sucrose into this sample bottle. So I'm going to prepare the sucrose in a suitable solution. The solubility of your sample is very important when you are analyzing anything with the NMR. If your sample is not soluble, definitely your signals are going to be rough, you are not going to get anything. So, first of all, you decide to use the right solvent, and not just any solvent. We use deteriorated solvent. Deteriorated solvent is what is needed. If you go and use any other grade, like an analytical grade, your spectra will be messed up. So here, I'm going to prepare a sample of sucrose using a suitable solvent, D2O, deuterium oxide. So there are other solvents like methanol deteriorated, acetone deteriorated, chloroform, and all the rest of them. But for this purpose, deuterium dissolved, sucrose. So that's what I'm going to use. So I take my spatula, and I'm going to take about 5 milligrams. 5 milligrams if I'm working on proton. But if I'm working on carbon, if I want to do a test on carbon, I'm going to take a weight that is much higher than 5 milligrams. So this is, I pick a sample bottle to prepare my solution in. I will take a little quantity and introduce just very little. About 5 milligrams. And when I do that, but if it is carbon, like I said, you need a higher weight or mass of the sample. You can need up to 15 milligrams. And the weight that you take also depends on the molecular size, molecular weight of the sample you are analyzing. So having done this, I will take my drop-in pipette, and I'm going to take out of my D2O, take a little quantity, I introduce it, I quickly cover this because I don't want to allow moisture to mess it up. So I'm forming a solution already. The solution is formed. I've got a solution of my sample. Then I take a sample 2. This is a sample 2. I open it and introduce my sample into it. So the next thing I do is to cover it and put it into the sample holder. Having done this, I will gauge it here. There is a gauge. So I have to make sure that the sample is in between this long line. So having done that, my sample is ready to be inserted in the machine. But before I do that, I must make sure that my sample is properly labeled, because we want to avoid mixing up people's samples. So what I have here is Workshop 1. Workshop 1. So I can give it same code. Workshop 1. My solvent is D2O. And the date I'm doing the analysis is today's date.
That's on 1st of October.
That's the 1st of October, or 1st of November. 1st of November 2021. So I properly labeled my sample. So I will go to the machine. Already there is a sample that is already in the inside of the machine. I have to inject it and place the one I want to analyze. So to inject, there it comes out. So in order not to compromise my sample, I will first of all go and replace this with its own label and save it. That's the one I was working before. Then having measured my sample, I'll get back to my machine and I start. This is a manual procedure. As soon as this yellow light comes on, it indicates that the sample has entered the probe. The equipment has accepted the sample. We could as well use the auto sampler. This auto sampler, in a situation where we have too many samples, we mount the auto sampler and you can key several samples and run it for a long time and get your result. So having inserted our sample, we'll come to the workstation. When you come to the workstation, you open the software. This is the software. You open it. We had this before, but I'm going for new study. This is new study. So having selected new study, I am going to first of all, let me shim the magnet. It's better to shim the magnet manually, because even when you start running the experiment, automatically the equipment shims itself. So when you look at this place, you see gradient shim. Now the magnet is shimming. We are trying to align the magnet in such a way that the signals will be smooth when it comes up. It's like calibrating the equipment. So it's taking its time to shim. Having done the shimming, we go to the next step. We tune the equipment. We are trying to tune the probe. So the probe we tune within the range of 100 to 400 megahertz. Is tuning. The pointer is at 100. Tuning is taking place. It has gone to 400 megahertz. When it's completed, it will tell us that it has been completed. So it's ready now. We go to auto lock. So trying to auto lock, we are trying to select an ideal lock for the experiment. You can see here the lock is at 27. But this lock is too low to run the experiment. I have to go to the lock here and make an adjustment. Make an adjustment, a maximum of 40. So I have increased the lock to 54. I still want it a little bit higher. I've got it at 86. So this is good enough. So the next thing to do is to run my sample. So I go to new study. I click on new study. After clicking on new study, I have to label my sample. I pick my labeling paper, and what I have as the sample code is workshop. Workshop 1. Workshop 1. I enter. It has accepted the code. Then I want to run proton. I go to the proton. I double click. Then I have to choose the parameters at which I'm going to run. So I have to double click on this. And here I can select the number of scans. I can select the relaxation delay. I can select the pulse angle. So let's select the number of scans. For the sake of the workshop, let's select a shorter scan. And also, sucrose molecule is not that of high molecular weight. It can easily resolve within a matter of 3, 4, 5, 6 minutes. So let's select the scan of 64. So having selected 64, I will save it. You will notice here that we have a maximum time of 3 minutes, 48 seconds. So because I am using manual operation, I'm going to come to foreground. It is already an automation. I can't run in automation because I'm not using the robot. I'm not using the auto sampler. Since I'm running manually, I come to foreground. Now I haven't come to foreground. I can now check my parameters again. I know the scan rate I have chosen. I can now submit. Submit. So you will notice here, it will register it's acquiring proton. So that's what is happening over there. So when you have commanded the equipment to run, automatically again, the equipment will resume itself. To be sure, it will resume itself. It will also do the auto-locking and will also tune, but it will do that very quickly. And immediately it has finished shimming and auto-tuning, the sample will pick up and start running. You can see here auto gain continued. The sample has started running. That's why you see this figure. But I'm also not comfortable with the lock. While it has started, I can still increase the lock to 70 to 80%. So that this power must not exceed 40. So here I have it at 76%. So this is good enough. So we are going to hang on for about 3 minutes. Then the experiment will be done. We can now view our results. The equipment is running. We have about 2.5 minutes to finish the scanning. then the spectra will be displayed. In a situation that we are using the auto sampler, you can key in several samples. Our auto sampler has about just 12 spaces. You can key in 12 samples and command it. And whatever parameter you want to analyze, the proton, carbon, the 2D, you can do that. And when you key it in, you take your time. After a period of time, by your calculation, you can revisit your equipment and view your results. So what is the time remaining? We have about, a minute and a half. Then the proton will be resolved. We start. So when it is done, you will see it here that it is done. Then we can view the spectra. So this is our spectra. We can increase it a bit. Yes, this is the spectra with D2. We have an issue here which we may overlook. Because we picked the sucrose, we decided to use something that is very common. This peak here is as an indication of water, which is supposed not to be. But nevertheless, we work with this. So here, if you want to process directly, which is not really part of this workshop, you can go to process, go to plots, assign integral values, go to parts per million, you get the peaks, you go to this line to select peaks. So the peaks have been selected. Then if you want to send this result, you can go to preview and continue to process it, save as, go home, go to desktop, then you say save. You close it. What we have done appears here on the desktop. So with this, we can send somebody a result on PDF. But more importantly is to send the result on FID file. So how do we do that? Now, here we will come to places, come home, go to NMR Res, then go to data. Our sample code is workshop. So here is a sample. So we right click, copy and paste it on the desktop. You can close this window. Now this is ready to be sent. But usually the FID file is a very heavy file. So we need to compress it. So we come to compress and we label it workshop compressed and enter and save it. So this is what we're interested in. So this we can send to your mail. You can go ahead, use your touch spin or metronova to process to your test. This is actually what we do before we get to your result. In summary, we have discussed what the equipment does, basically for the elucidation of structures, whether it's natural products or synthetic products. We have discussed the three basic units of the equipment: the console, the magnet, which is the NMR, and the workstation. We have also shown and demonstrated to us how you can prepare your sample, and that you need to prepare it in a deteriorated solvent, not analytical grade or whatever. And when you prepare, you showed us how we inserted the sample. And after insertion, of course, you have to properly label your sample. After insertion, you come to the workbench and set the necessary parameters and run. Now what we're going to do again is that we're going to take a further step if the time will permit it. We are going to run the carbon spectrum We run the carbon, and it may interest us to still in this workshop to run the Dept. And we pick one of the 2Ds, we can run HNVC or HQC. So here we want to run, we say continue study. When we click on continue study, we go to carbon. Carbon, we double click. We go to default carbon 13. Like we did for the proton, we set the parameters. Let's put it at 64. At 64 is giving us how many minutes here? 2 minutes is too short. Let's go for a little bit higher. I don't want it to be too high because of our time. Let's go to 512. 512 is giving us 19 minutes. It's on the high side. It's on the high side. I want to give it a number of runs that will not take much of our time waiting. 19 minutes is high for me. So let me check. Come on. This is still too short. Too short. Let's pick the default time, which is very, very short. I just pray that the resolution will be fine. If we are to take the default, we have to take away this and bring the carbon again. The default timing is 8 minutes 40 seconds. So let's take the default timing. I can as well put in the other parameters. I go to studies. Here we have Dept. I don't want carbon to run twice. I remove it. The Dept is going to run for that. Let's just use the default. I'm sure we get something that is equally good. This is Dept. Keying cozy. This is cozy. I give my cozy some, change the parameters, give it about 8 minutes to run, about 400 scans. Then I will pick HSQC, still 8 minutes. Let's take the default run. Then GMBC is going to run for 34 minutes. Can we be able to wait for this? Let me remove it. Since this is just for demonstration, we have reduced the timings to the barest minimum to conserve time. So having set all the parameters and everything I want to run, I'm going to run carbon, I'm going to run Dept, I'm going to run proton. Okay, proton again? No, I have to remove this proton. Yes, because if you fail to remove it, it can use your 2D to be comparing with this, which we don't like. So, having done that, I am good to go. I click on this tab, pick foreground, and I will submit. It will start running the carbon. It will start acquiring the carbon, like you can see on the screen. So we have to wait for it to finish acquiring the carbon. Maybe we will check how the process is going. You can view the carbon when it is still processing. So they will have to give it about 1 to 2 minutes before the machine starts registering the FID file. If you want to open it now, you cannot see anything. It's only when it has stayed for some minutes that you start registering the FID file. And right then, you can begin to see how the carbon is developing. So I think you can keep the video on, and Give it for a few minutes, about 2 minutes. We are working from 9 minutes. So having had this experience, let me also get the appropriate lock manually. So this is 54. Get it at 77 or thereabout. So our carbon is running. Carbon is running. Let's give it about 2 minutes. The first minute is gone. Then we can view and see what is happening. So while the carbon is still running, let's view it. Yes. Yes. This is beautiful. So it has run for about 4 minutes, and it has resolved to this extent. The higher time or higher number of scans you give it, the better resolution. This background noise can become as clean as a straight line. Then we gave it only 9 minutes, 52 seconds. And as a matter of fact, having run for a short time, we've got our carbon. It did well. But this is possible because the sample we are using is of a low molecular mass. And the sample size is relatively high. So in most cases, especially when you are running a natural product, in most cases the samples are small, scanty. And sample size has a lot to do with the length of time of running. If the sample is very small, the time your sample will stay in the machine may take a very long time. 3 hours, 6 hours, in fact in some cases 9 hours. The things that contribute to your sample spending time in the machine is one, sample size, and secondly, the molecular weight of your sample. If the molecular weight is very large and the size is small, your sample is going to take a very long time in the machine before it will resolve. So having said that, we're also going to give this one time for the Dept to run, the COSY will run, the HSQC will run, then finally we will look at the result and the FID result, which we cannot view here, which we normally send, like the way we describe when we run the proton. So we have about 40-something seconds. It's coming down. Immediately the carbon finished. Okay, let me see the state of the carbon before it will finish. You see the noise has reduced a little bit further. So when it finishes now, the Dept will come in and it will run after finishing the Dept, the COSY, the HSQC. Then we come and view our results all together. So you watch the timing. 8, 7, 6, 5, 3, 2, 1, 0. Carbon is finished. Now it's setting up Dept, acquiring Dept. The same thing will happen when it has finished running the Dept. It will jump to COSY, and thereby later when the COSY is finished, it will jump to SQC. So we'll be done with the experiment.
70 something. It will absorb 70.
Okay, you're picking it. Yeah, it's acquiring cozy now, one after another. After acquisition of cozy, it will acquire HSQC. Then we'll be done. We'll go and look at what the results are like.
The code for the absorb 70 something. And the kids usually.
So the cozy is about to be rounded up, and immediately after that, HSQC will start running. It's processing cozy. Has taken over HSQC, acquiring HSQC. So this is going to run for the next 8 minutes or thereabout. You can see it here. So after that, we can now begin to consider how to process our results. So we are getting to the end of the experiment. 4 seconds remaining. 3, 2, 1, 0. So the whole experiment is done. So we can view. Let's start with our carbon. Wow, I like this carbon. Yes. This is the spectra of sucrose. If we give a little process in here, we can do this. Pick all the peaks. I want to pick this one here. Yes. So, it's going above the window. We can come down here and bring out this line still to pick that. Yes. Can still get it out to reduce the noise so it will appear beautiful. Good. If we like, we can expand it, pick this, drag it, then pick this one here, then enter. We want to expand it. Let it come. I want to expand the spectrum. Let's see what happens. So expand. Good. Yes. Good. This is how sucrose spectra looks like, carbon-13 spectra. You can confirm this in the net. You can check the standard sucrose in the net and compare the spectra. To the best of my knowledge about this equipment, it replicates the standard. Let's fix in the peaks. ppm. Come on. Let's get the peaks. Sufficient to appear. We'll get it. So let's go back. Let's go back and pick the picture. Yes, it has come again. Blah, 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 blah. Pick this baseline. I still want to pick this one here. So with this, you can send the PDF just like we did for the proton. Let's look at the Dept. This is the Dept. Very good Dept. Very good Dept. With very less noise. You can still reduce the noise and do a little processing here. Go to basic, preview. That's it. We can send this in form of PDF. So let's look at the cozy. Let's expand it and see what we can get. They are coming. Yes. You can also process this. process the cozy. If you want to send by PDF, you send. Okay, there we go. Look at HSQC, a 2D experiment. So you can expand it, you can process it a little bit, send by PDF. So we may want to close our window if we like. We want to get everything into FID file. So we do what we did the time we did Proton, go to places, go to home, go to VNMSR, go to data, then locate our file name, workshop. So everything, 6 items are here now instead of 1. So we copy it, take it to desktop. It's replicating, because when we did the Proton, we gave a name, so we need to rename it, so we can put it workshop complete, okay. We have now renamed it. It will answer us. Copy, paste. So we close this. We look at our workshop complete. To send the FID file, we compress it, because to send through email, the size of this file will not go. We compress it. Compress. Workshop complete. Compressed. Enter. So close. So workshop complete. So this is what we can send to the email. And when it gets to you, you can now use your touchscreen or Metinova and process it to your design. I think this brings us to the end of this demonstration, the NMR lab. Of course, it may interest you to know that this is a complete lab, because we have other supporting equipment like the FTIR, GCMS, and HPLC. We have triple quad ACMS, ICPMS. There are several of them. This is one of the sections of the lab. So in a situation, particularly people that are running synthetic compounds, and you want to be checking your sample at every stage, as a matter of fact, you need to test your starting material. If NMR is too costly for you to start with, you can start with FTIR, at least to know the functional groups that are present in your starting material. So when you are sure of that, and you start your reactions, when you are getting to the end, you can now come to the NMR. That may reduce cost. If there are intermediates you want to check, you can also check with those lower equipment like ATI, which does not cost much. As a matter of fact, it is a little bit costly to maintain the NMR. That's why the charges. For now, the minimum, if you are running proton and carbon, the minimum is 30,000. When your sample stays much longer, the cost increases. Once again, my name is Silas Ekwide, the laboratory manager of Multi-User Science Research Laboratory, A.B.U. University. Thank you for listening. Thank you.